Hi, this is Alan speaking, and I want to take you on a tutorial of the HiTechnic sensor Experimentor's kit. I've been having a lot of fun with it, and I wanted to share with you my experience. I also want to make the point that the Experimentor's kit is perfectly adapted to use in the Lejos programming language. In the kit, you will see experiments that are written in NXTC and NXTG, but nothing in Lejos. However, these programs are very easy to write, and I will be sharing them with you on my blog. It's also my hope that the folks at HiTechnic will also include these sample programs in their website, so that those people who are using Lejos will also be able to access this product more easily. So here's the setup. We can see that there is the NXT on the left. It's connected by a cable, and there you see on the prototyping board just at the left, and I'll point with it with my finger, the sensor board. And it sits on a prototyping board. I have set up here experiment number 2. Let me just show you how the prototyping board works, and then I'll go into all of the details in a moment. I'm going to take the NXT and I'm going to turn it on, and I'm now going to run the program that I wrote, and you can find that program called Experiment 2 on my blog. The program is now running, and we can see a little red light that has illuminated on the sensor board, indicating that power has been sent to it. You'll see a little blue device that I now have my screwdriver over. That's a potentiometer. It's basically a variable resistor, and now I'm going to turn it, and I think that you can see that by varying the amount of resistance, I can switch the lights on and off. But what's important to understand here is that the lights are not being controlled directly by the potentiometer, but rather the lights are being controlled by the NXT over here. The NXT is making the decisions about which lights should be turned on or off based upon the current that it is sensing through the sensor board. Okay, once I take my screwdriver out and I turn the program off, you'll see that all of the lights turn off, which again shows that in fact it is the NXT that has been controlling this. And when I turn the NXT off, the light to the sensor board goes off as well. Okay, I want to show you next the program and how the program actually works. Let me just scoot up to the top here. There's many different things that are going on, but what I first do is I create an instance of experiment number 2, and I also pass to it sensor port number 1, and I do that so that, as we can see over here, it is in fact connected through sensor port number 1. I set up a read buffer consisting of 2 bytes. I set the input data to 0 and the output data to what is bit null. Bit null, basically all bit null is, it is simply byte 0. Now we go into a while loop, and while the escape button is not pressed, what I do is I read data from the buffer address. What I'm really doing there is I am reading the amount of current that is being sensed across the potentiometer. Now, I'm not going to go through all of these calculations, but suffice it to say that what happens is that I am taking the input data and converting it into a usable number. I do some LCD displays, and now I set the output data to bit null, to 0. The next thing that we do is we go through a series of if statements. And those if statements decide which bits are going to be set ultimately in the output register. Now you'll notice that there's a total of 6 bits that need to be set. And if we look at the HiTechnic, there are 2 green LEDs and there are 4 red LEDs. So to be concrete, bit 0 is the green LED at the extreme left, and bit 5 is the red LED at the extreme right of your screen. All the others are numbered consecutively in order. So if we look at the program, what the program is doing is it's basically deciding which bits need to be set. The higher the input value, the more bits get set. Then in this line, we simply send the output data to the write buffer, and that then sets the bits, and as you probably can already surmise, it then determines really which of the LEDs get lit. Once the while loop is broken here, we then send bit null to the write buffer. We have to do this so that when the program closes down, it cleans up its mess, and basically by sending a 0 to the write buffer, it sets all of and turns off all of the LEDs. If we didn't do this step and there was a non-zero value in the write buffer, then all of the LEDs that we see here would still be on, and they would remain on until we cut the power. So for those of you who are interested in looking at I2C types of sensors and you want to build your own sensors, then this is a great project and it's a great investment in trying to understand this program. Now what I'm going to do is just take a look at detail of the circuitry to help you understand. And I'm just going to put the camera down here. I'm going to disconnect the prototyping board, and I'm just going to show the prototyping board to you. Now if we take a look here, we can see the potentiometer here, and we can see 2 orange leads. Those 2 orange leads are actually connected to the analog port, and that's where the analog port up here is getting the necessary input value. The red lead that you see here, this red lead here is actually getting the voltage for the potentiometer. You'll see an array here of 6 resistors. Each of them are connected at the top side to each of the bits, the 6 bits for the output register. On the other side, the registers are connected to each of the LEDs, and the cathode side of the LEDs are actually connected to ground. As you can guess, when one of these bits is set to 1, that causes a current to flow through the resistor and into the LED. The LED illuminates and it comes on, as you saw earlier in the diagram. So if you're thinking of a new project, I highly recommend the Experimentor's kit from HiTechnic. Thank you, and if you've got any questions, put a comment on my blog. Bye for now.